Hello and welcome to Let's Learn .NET Containers. I'm Jamie Singleton, but I am joined here with expert and good friend and great colleague, Chet Husk. How are you doing today?
I'm doing great. I'm a little flattered. Expert. Wow.
You are, especially in what we're about to talk about today, covering, we're going to build our first microservice with .NET, and then we're going to deploy .NET microservices to Kubernetes.
Yeah, we've got a nice 1-2 punch lined up for everybody tonight. I'm really excited to get started. This is something that I've been doing professionally and in my time at Microsoft for quite a while now, and it's amazing how far not only microservices as a concept have come, but .NET has come in supporting microservices, both from like a coding perspective and from a tooling perspective. And we're going to see a lot of it today.
Yeah, it's amazing to see it come so far. And you're so humble. You've been with the product for so long. You are definitely our expert here. So I'm looking forward to getting started. Let's go ahead and kick it off. So I'm going to add your slides to the page. There we go. And I'll let you take it away.
Awesome. First off, hi everybody. I'm looking at the chat here, and there are people from all over the world. So we're going to have a pretty broad audience for today. I think we've got every continent on here so far except Antarctica. So I'm waiting for all the people at the research labs down there to chime in. Today we're going to talk about microservices with .NET. We're going to talk sort of conceptually about them, what a microservice is, and we'll talk about a few different ways to deploy them with a special focus on containerization. As we go through the content for today, I wanted to draw your attention to this link on this slide here. The folks from the Learn org and Microsoft have put together wonderful, wonderful learning guides that we are going to be actively working through today. So if you want to follow along, if you want to do this at the same time that I am, you should be able to replicate everything we're going to do today on your machine at home. If you've got two monitors, keep us up on one, bring up the Learn module on the other side and work through it. And this isn't going to be like straight through the content either. We're going to have some detours. We're going to go deep on some sections, and we're going to have plenty of time for questions that you all have as you're working through it, either seeing what I'm doing on screen here or working through your scenarios at home. Yeah, so we're already seeing some really interesting questions pop up in the chat. Also, I got to shout out Chris Funk 21, my fellow Texan. Welcome. The first question that I see pop up in the chat here is from AM saying, I'm here for the first time. Will writer work for this? First off, welcome. Super awesome to have you. Nothing that we're going to do today is specific to writer, but the things that I'm going to show will be using tooling in Visual Studio Code and GitHub Code Spaces. So there are command line alternatives for many of the things that I'm going to show. And I will try and put an effort on showing some of those CLI versions of these things. But for ease of viewing for everybody else, there might be an emphasis on some UI tooling as well. I'll try and make sure and call out when there are command line alternatives to some of the things that we're doing. So we've got everybody on board. I've given folks some time to go to the links here. Let's and we've said hi. I guess I could pause here for a moment and talk a little bit about me and my background. I mentioned I've been doing this for a while. I've only been at Microsoft 2 years now, working as the product manager for the .NET SDK and containers and MS Build. Before that, I was working in industry. I worked at several startups. I worked in the education space. I worked in e-commerce. The one common through line of all of those different jobs, though, was they were microservice focused. People have been doing microservices now as a design for their system architectures for many years now. I got my first taste of it in an e-commerce job coming out of college, and it has continued to be a recurring theme here. Before we talk a little bit about what microservices are and how you can think of them, I wanted to sort of prep you with what you'll need to be successful for the session if you're going to follow along at home. We will be showing command line tooling. We will be showing VS Code, so familiarity with both of those will help. We will be talking about Docker, and we'll try and give you a good grounding of Docker and container concepts in general. But if you've used Docker before, you'll have a bit of a head start here. We're going to be showing both command line and UI tooling for all of these things. And actually, one more prerequisite here. If you want to follow along with Codespaces, you'll need a GitHub account. Some amount of Codespaces usage is free. If you've been using it really heavily, there might be some charges involved. But for the most part, everything that we're going to be doing here today, you should be able to do with no cost. So as we go through the content today for this first section, where we're talking about microservices and we're talking about containerizing them, we're going to try and establish a baseline of what a microservice is and how you might think about making one, how you might think about a system that is made of microservices. We're going to talk about some of the technologies involved, typically with microservices like Docker. And then we're actually going to, get our hands dirty and build a microservice using .NET and a whole bunch of tooling around .NET. And here's the brief summary of like a retelling of what I just said, sort of the main sections. If you're following along with the Learn module at home, these are going to be the section headers that you will hit. There'll be a little bit of Q&A, maybe a brief quiz as we go through some of the content. So stay engaged, stay ready, because I'm going to try and keep you on your toes. All right, so before we get going, there are a few questions I think we could hit before we dive into the content. The first one I think I want to address is Johan Viklands, and I'm from Texas. I don't know how to speak all of the languages that are on display here today, so please forgive me. Please bear with me if I accidentally mispronounce your name. Anyway, Johan asks, how many layers of microservices before the system starts to get slow? This is something you might hear about, and I'll actually have a bit of a diagram to describe why you might think it might be slow a little bit later on. But the short answer is there's no inherent reason why a microservice architecture should be slow. There are a whole bunch of techniques that you can use to ensure that a microservice architecture stays fast, like caches and separating your read databases from your write databases. But there's nothing inherent to the architecture style that causes these to be slow. In fact, some of the tooling that we might look at today and some of the tooling that Microsoft is currently working on, like Aspire, often brings ways for you to performance test your microservice architectures and figure out where the bottlenecks are. There's a second question in the chat from Andrew Allshouse, who says, what specs do you usually run on your professional PC when working with containers? I've noticed Docker and Visual Studio eats lots of RAM. That's fair. The answer is going to change a little bit depending on what operating system you're using. So if you are using Windows or Mac, you're going to have very similar problems here because the containers that we'll be talking about today and the containers that many people think of first when they think about containers are Linux containers. And so you need a Linux host. You need a Linux virtual machine or actual machine to run these containers on. And we'll talk a little bit more about that in a bit. So Windows and Mac OS don't have or aren't Linux. So you have to bring a virtual machine to act as that host for your containers. On Windows, this is very easy with WSL. Like you can just start Windows, launch a terminal, and write WSL and have an environment to run your containers on. With macOS, it's a little bit more work, but Docker, the company, has provided tooling that will set up that virtual environment for you or that virtual machine for you and give you a place to run your containers. That need for an entire separate machine to run your containers on is, I think, where the perception of lots of RAM comes from. So if you have a Linux machine, generally you can have a lower spec machine to run the same amount of containers. So these days, me personally, I have a machine that I use for work and a machine that I use for personal development. And my work machine has, I think, 32 gigs of RAM on it. And that allows me to run many containers at the same time without having to, without running into too many resource constraints. So that's something that you might have to dig into with some detail based on the kinds and the number of containers that you are using. Final question here is from Alejo Mio, who asked, how do I get Azure Container Instance working with the .NET 8 default port change to 8080? There's a lot to unpack here, and we'll actually see some of this when we get to the second module about Kubernetes. But what's happening here is that in .NET 8, ASP.NET changed some defaults about the way that it deploys. And we'll see that in our code a little bit later on. Typically, a container would use port 80 in the past, which is what you sort of expect when you go to a website. You're on port 80 for HTTP and 443 for HTTPS. But that has some security problems, especially with containers. And so in .NET 8, we moved over to using port 8080 by default. And that means that you would need to go to your configuration for your Azure Container Instance or your Kubernetes cluster or whatever, and tell that infrastructure the new port. You can also do a thing that we'll see a little bit later and tell your ASP.NET application to use a different port. I'll try and remember to call that out explicitly when we get to that point, Alejo. Thank you all for your questions. Okay, so we've gone through, I guess there's one more question. Why not using Windows containers from Paolo Maculan? We're not going to focus on Windows containers here just because, in my experience, Linux containers are more broadly used, and they're also much smaller to get started with. The Windows container images, because they bring along Windows Server, are very large, and that means that when doing demos or classes or things like this, they are much larger downloads and they take much longer amount of times to push up. They're still very valuable, especially if you are using applications that only run on Windows. They're just not going to be the focus of our time today. Okay? Cool. So that's the questions. Let's dig in. I'm excited. So the main theme of this first part is sort of talking conceptually about microservices and making our own. I've said this word like 20 times at this point, but what is a microservice? You can do a little bit of etymology and sort of break the word apart. You've got micro for small and service for a thing that you want to work with. And that's the truth of it at its core. It is a small, independent unit of functionality. If you picture sort of code organization as a scale from a single line of code to an entire complex system, you might start with a single line of code, and then you might have a function, and then you might have a class, and then you might have a namespace, etc. A microservice is just another stop along that sliding scale. What you want to try and do with your microservices is find a unit of code that is completely independent. It's not used directly by other locations. There's no code sharing, and there's a clear interface, right? We call these domains. Ideally, you want to find an isolated domain and enforce a boundary, and a microservice can help you do that if you can wrap a boundary around that unit of functionality. And what that lets you do is independently deploy and independently change that unit. If you think of your code, you probably have different classes that talk to each other. And these classes communicate with each other using methods. There's some sort of API between class A and class B that describes how A can talk to B. Microservices are that, just at a slightly larger scale. You enforce the way that people can change your data or alter your data by exposing a limited API that you can control and change independently of the rest of the system. So you see this a lot in enterprises, but it's also a pretty natural pattern to fall into once you've started using it. So it's not just enterprises. You do see them a lot in enterprises, though, because they allow scaling both of individual components of code, but also of teams. Individual teams might own specific microservices or specific sets of microservices and focus on improving the performance of those or expanding their capabilities, right? In this way, this is just a larger version of what you might already do with your teams when you write code. You decide on an API specification, and then once that specification is set, the consumers of that application can go write their code, and the people implementing the API can go write their code. And if you did it right, they meet in the middle, but they didn't have to check every single concern. In English, we would say they didn't have to cross every T and dot every I, right? Same idea with a microservice. So we've talked a bit about what they are. They are an independent unit of functionality. They are ideally completely in control of their data. And they are a unit that can be developed and deployed independently. There are a bunch of details here, and there's a weird video link that did not render well if you want to go view this on your own time. But these are kind of key to microservices, that ability to completely own that slice of code. And we will see an example of this in our example or in our exercises a little bit later, right? There are other organizational benefits as well, right? Because each microservice can deploy independently and can be developed by different teams, you are more free to make technical choices that are appropriate to each specific microservice. An example of this might be that if you had a specific library, say for video encoding, that only had a library that worked in Rust or something, you could make a Rust microservice to interact with that library. Or if you had a Windows only, .NET only, we'll say like some kind of SQL driver for a specific kind of database you wanted to use, you could just as easily make a microservice to allow other teams to use that resource without having to use .NET on Windows, right? They support polyglot programming in this way. You will often see or hear the phrase, use the right tool for the right job in the context of microservices. And this is one of the reasons why. Each service can use its own implementation language. It can use its own database. It can use its own coding patterns and practices, whatever your teams and your organizations decide is best. And that's very freeing. In my history, I've worked on sort of the opposite of this before, monoliths, big balls of mud where everything was tightly coupled together. And because it was all one tech stack, the decisions were already made for you. And sometimes that leads to subpar results. So microservices are freeing not just from an organizational perspective, but also a technical perspective, right? So we've hit most of these points in the chat so far. There is one question in the chat, I guess, that we can touch on real quick. Foolish Snable, I think I recognize you from some previous live streams, so it's great to see you again. Foolish Snable says, microservice is an organizational pattern to enable hyperscaling of an org. I don't know about hyperscaling, but to me, microservices enforce good communication, right? When you have a microservice, that service is establishing a boundary. That team is establishing a boundary. And so you define up front how other people can call you, how other teams can use the resources that you provide. And that's good. That's just establishing a contract, right? And that is the kind of thing that good teams are doing or should be doing anyway. Microservices just help enforce that behavior. There's a follow-up question to this in chat from Andrew Allshouse again, who asks if I can speak to some of the disadvantages or challenges associated with microservices and how have you solved these? Why, yes. One rule of thumb I like to have in my pocket is if somebody can't tell you the downsides of a thing, they shouldn't be talking about a thing. So let's talk about some of the downsides now that we've talked about some of the upsides. So the first and foremost, I can actually use examples from Microsoft ourselves, right? We don't just make .NET, we also make a lot of services and tools and products, right? The flexibility of microservices has allowed us to make architectural decisions that are best for each stack. But that doesn't mean that there aren't things that have to be done for every microservice, right? So an example of this might be that Microsoft products, we serve a global marketplace. And so we need to localize all of our products and services. How exactly you do that is different depending on each tech stack. In .NET, we're very familiar with like regex files for localizing resources. If you've used JavaScript before, you've had to localize and make your front ends internationalization aware, which isn't just text, but it's also layout like right to left and this sort of thing. A good organization will establish standards for capabilities that have to be met, like localizing your public-facing resources, but they won't mandate how necessarily. And so that means each of your microservices or each of your different tech stacks have to figure out how to implement that, right? So that's a downside. Sometimes you have to figure out different ways of solving the same problem. In the extreme, instead of solving this problem separate ways in different tech stacks, you might see companies or organizations mandate tech stacks so that they can use the same like solutions for localization, right? So that kind of complexity, that cross-cutting complexity that has to happen across every product can be harder in microservice architectures. It can also be harder to negotiate and consume those APIs we were talking about, those boundaries. This is where you see technologies like OpenAPI come into play, or GraphQL, that attempt to give you a consistent way to describe your microservices and then consume them, right? And it can also be somewhat difficult sometimes to manage versioning or breaking changes of a microservice. These are all very detailed topics that sort of come in after the initial development of microservices, but they are things that good teams should be talking about early, right? So that's hopefully that was a complete enough answer, right? Yeah, so we've talked a lot about microservices. There are a few more diagrams that cover things that we've talked about because I sometimes ramble for a bit. They've talked about the capsulation or the encapsulation of domains and requirements, which we'll see in our example later. But one thing we haven't talked about for microservices is what the role of containers are. And this actually aligns really well with the question that Joe C. in the chat has right now. Joe says, with microservices, what advantages are there for putting it inside a container versus not using a container? It can look like just another level of complexity. And so to me, the answer for this is the opposite of complexity, actually. It's uniformity, right? If you think back, say 10 years ago, there are a bunch of different ways to host a web application. You have, we'll say you've got like Nginx as a load balancer. You've got IIS doing the same role. You've got on Python, like, what do they call it? Like uWSGI, I think, or something like that. But in every case, you needed some kind of load balancer in front that would find requests and redirect them to your application and handle concerns like load balancing termination and this sort of thing. And every app had to be downloaded to the machine and installed and configured separately based on its tech stack. In .NET, This might be something like a click once deployment package, or zipping up and unzipping to a particular folder and then doing IIS configurations or your own Nginx configurations. Containers provide a way to provide a consistent way of managing all of that. If your application is in a container, you have only a few ways that you need to know about in order to configure it. You can package it up in a uniform way, the container. You deploy it in a uniform way by pulling a container image, and you run and configure it in a consistent way via container environment variables or volume mounts or anything like that, right? So what containers give you is a uniform deployment and management layer for all of your applications, for all of your microservices, right? So that consistency, that uniformity is the most important thing for me. And on top of this layer, you see this huge ecosystem of tools that help you manage this. You see deployment tools like Octopus Deploy. You see container orchestration tools like Kubernetes, which we will dig into a bit later today. And you see this like operations and monitoring tools like OpenTelemetry all layer on top of this to give you a better sense of how all of the different microservices you have are deployed. So it's that uniformity, right? There are a few more questions sort of about the operating system that we're going to use for our containers. It's going to be Linux today. Smaller, like I mentioned before, they're smaller than the Windows containers. And the deployment tech that we're going to use, Kubernetes, all of our nodes are Linux there as well. So we're just going to stay Linux through and through. And yeah, Jenny asked if I'm referring to building APIs using .NET and deploying to Azure Kubernetes Service or Docker containers. Yes, that's exactly what we're going to do today. Use .NET to build microservices that we deploy using Docker containers. So I've said Docker a bunch of times here today. There are a few different ways we'll be thinking about Docker. Docker is a company that produces a tool that we are going to make use of today. On Windows and Mac, they produce a really nice UI called Docker Desktop for Windows and Mac that makes it very easy to get started with Docker. And what these tools do is help you build your containers, store your containers, and then run the containers. And we're going to do all of those things today. Originally, when containers first came out, the Dockerfile was the only way that you could build containers. We're going to look at an alternate way today, but no matter how you build the containers, you still need ways to move the containers around and store them and reference them. And then you need ways to run them. So we're going to dig into these different parts of Docker and containerization more generally next. I've said container a bunch of times. We're just going to level set here a bit. A container is a packaging of an application and an operating system and all of the dependencies that are required in one single deployable unit. It's made up of a bunch of other small parts that we will hopefully dig into, but from the outside, it just looks like one thing. And you get a unique name for it that you can reference, and you can reference that name with tools like Kubernetes or tools like Docker locally to run always the same version of that application. So when we say an image, what we typically mean is a template, if you will, right? This is not something that is actively running, but it's a description of your app and what it takes to run. And then when we run that image, we get a container that is actively running, okay? So that's the distinction there. To get these images, like I said before, we can use a Dockerfile, or now we're going to see something new and fun. You can actually build containers without needing a Dockerfile directly from the .NET SDK. And we'll be working through that when we get to the exercise portion of this today. But this should look very similar to what you do when you publish your web app today. You create a web app, and then you call publish, and you get the published application. Well, to get the published application in a container, you do that same call, you just have to specify one more little flag, which is to tell .NET to publish a container. And that's all you have to do. We'll see that live. And I really like this feature. It reduces a lot of the complexity of Docker files that can be hard to keep track of sometimes. Maybe we'll be able to do a compare and contrast a little bit later. So we talked about microservices. We talked about containers. We haven't talked about .NET. Have folks here, do you have familiarity with .NET? Do I need to sell you on .NET as a cloud-native, cross-platform, microservices capable languages, framework, and tools runtime? I hope not. You should be convinced. And if you're not, I'm going to direct you over to Stephen Tobe's .NET 8 performance blog post that he released this past November. That was a huge number of pages all about performance. .NET is cross-platform. .NET is fast. .NET tops charts. We love .NET. And with the investment that we've been making in Aspire and our cloud-native computing, it's better than ever to build microservices. So there's a really great question, again, by Fula Snobble in the chat that says, I don't know what cloud-native is, though. Big, giant umbrella of functionality and features go in this term of cloud native, but broadly what it means is that your application is designed to take advantage of resources available from a cloud provider, to be inherently scalable, to support things like retries, to support being deployed as a microservice, to have built-in support for observability and monitoring and tracing, all in, like, all batteries included from the get-go. So that's what cloud native means to me. It's one of those things, though, where when you talk to different people, you'll get slightly different versions of the same definition. So I mentioned that we were going to try and keep you on your toes. And now we're going to see how much you've all been paying attention. And if y'all don't chime in, I might have to see if Jamie's been paying attention. So we're going to start quick quiz, 1 or 2 questions, maybe 3 at most. All right. This will wake us up, get the neurons firing, and then we'll go do some code. Question 1. Which of the following scenarios would be a candidate to become a microservice? Remember, when we talk about microservices, we're talking about specific domains that can own all of their logic and code and data storage. Is it A, a web API that returns a list of pizzas? B, a web API and a website that return and display a list of pizzas? C, a website that's deployed by using GitHub Actions? Or D, a Docker image? We're going to give it a few minutes. I want to see what everybody thinks. Well, not a few minutes, but just a bit. Seeing lots of A's, a couple D's. Okay. I'm seeing that Fula Snobble might need to find some new friends. According to them, their friends use all of the above answers. All right. So there are quite a few different answers in chat. I'm seeing mostly A's, some D's, and a few B's. I'm going to cut it off there and we'll see what the right answer is. The answer is A, a web API that can return a list of pizzas. So quickly, let's go over why some of the other ones. Oh, I forgot about the pizza gif. So why wouldn't it be D, a Docker image? Well, in this case, a Docker image could contain more than just a microservice. It could contain a monolith, an application that had multiple areas of responsibility in it. It's also not B, because B is a web API and a website that returns and displays a list of pizzas. The idea of microservices is that the API with the data and the UI with the display are separate concerns, and each of those should be handled and deployed and developed independently. Okay. Question 2. What purpose does a Docker image have in a microservices architecture pattern? Your choice is only 3 here, so you've got a better chance. A is it's a text file with instructions for how to build the microservice. B is a Docker image is a static representation of a microservice, its configuration, and its dependencies. And finally, C is Docker images allow hosts to perform load balancing and routing. All right, again, answers in chat are flowing in. I'm seeing a lot of B's, a couple A's. A lot of B's. Yeah. I think everybody's got it this time. Yeah, overwhelmingly B. The Docker image itself, as we mentioned, is your app, its dependencies, how to run it, all in one package. And when you run it, it becomes a container. So good job. That was very on point. There were even a couple clarifying questions and answers in the chat. Like Zelko asked, but website can also be deployed as a microservice, right? And yes, we'll actually see that a little bit later. For this question, the web API, the web API and the website would just be separate microservices that deploy independently. Our final question is, why would a developer write a Dockerfile? Is it A, to create some kind of initialization routine for the Docker engine itself? Is it B, to create a text file with instructions about how to build a Docker image? Or is it C, to write the code that's actually in the microservice? Jamie, I think we made this quiz too easy for these viewers, because they are almost all nailing it. It's B. A Dockerfile is a text file with instructions for how to build a Docker image. Your code can be in any language. That's why C isn't the right answer. B describes a way to make a container containing code in whatever language you want. Okay, so there was a question in chat as we were going through the quiz. Will there be a practical example? And yes, we are at that stage now. So everybody stretch a little bit, get those typing fingers ready, because we are going to pivot now and actually look at a .NET microservice and build one into a container. Okay? Remember, Jamie, if we can flash the link up again, remember everything we're going to do here is in a Learn module that you can follow along with at home. So when I'm about to bring up my code space and start also some code, you can do the exact same thing that I'm going to do. All right? Okay. There are a couple people in chat who are curious about the answer on that last question. I kind of agree with you in spirit. We can maybe work on the wording of the question to express the intent better. So, okay, so here is the problem statement of what we are going to do today. We have a sample repo that I'll show in just a moment that has two services that we would like to build and deploy because they go together. One is an API that returns a list of products for a storefront, and the second is the UI for that storefront that can display the list of products. So broadly, what we're going to do is we're going to initialize our development environment and talk about it real quick. We are going to publish container images for these services, and then we are going to run them and check that everything worked. Okay? So with that, I'm going to go over to the code. All right. Oh, I waited too long. I need to restart my code space. So we'll let that come up real quick again. And Jamie, because I'm going to be on a different tab, if there are good questions, I'm going to need you to let me know, okay? All right, so as we wait for the code space to come up, this is all giving you all plenty of time to load up your environments as well. I'm going to talk a little bit about what is in this setup. So we are going to be in the .NET Docker project folder of the mslearn.net Cloud Native repo. All the samples we're going to do today and many more are available in this repo, and they will follow along with the learn path that you have at home. Okay? So what are we looking at in .NET Docker? Well, primarily we are looking at two projects. The first is a products project, which has a fairly simple web API. We are using SQLite, and we have some API endpoints, and we have some initialization routines. If we go look at our map product endpoints extension method here, we are serving a few API endpoints off of the API product route. We've got one route that lists all of the products that we have. And we've got one route that gets details for a specific product by its name, get product by ID. That helps you understand what it's doing. We also have a put call to the same path that lets you update a product. And then finally, we have a post to the root that lets you create a new product. And not quite finally, but you can also delete a specific product. This is an example of a pattern we call CRUD. Create, which is the CR, update, which is the U, and D, which is the delete. This is a fairly common pattern, and you'll see it for lots of different entities. Not all entities or domains, like products, will support all of these, but it's generally like an okay mental model to have. There's a little bit of entity framework scaffolding to set up the data store for this. But other than that, that's it. That's the whole microservice, just products and managing products. Separately, we have the store project, which is a UI, a Razor and Blazor UI that uses the product service. There are some configurations that let you connect to an API for the product service and read its data. So this was auto-configured for me when I made this code space. But in general, this is one of the problems that you have to manage with microservices. You have to tell your services how to find and communicate with each other. This is a process called service discovery, and it used to be very hard and manual. And there are tools like Aspire, and there are tools like service discovery frameworks for Kubernetes and things like this that help get rid of some of the pain here. We're going very manual for this today because it's a very simple example. So we have two services here that we want to use. So if we want to deploy these somewhere, we need to containerize them. There are two primary ways to containerize that we use in .NET today. And the historical way has been something called a, I just accidentally closed my code space. So I need to bring that back up. Give me just a moment. All the best stuff happens live. All right, here's the one I want. All right, bringing this up. Let's go back to Streamlab and share it. Okay, we're back. So like I was saying, there are two ways to create a Docker container that are common in .NET today. The first is the oldest. It's using a Dockerfile. They don't actually have this anymore because we're trying to show a different way, but I wanted to let you all know that this does still exist. If you want, you can use the Docker tooling for VS Code to actually create sort of default Docker files for a project. So let's take a look at what that looks like real quick for our products system. We'll let this generate this. So this is a Docker file. We talked about them briefly a little bit earlier, but what they do is describe how to build your entire application in a Docker container and then package your application for delivery, for distribution, for execution. Okay. There are multiple stages here. There's a lot of kind of inherent complexity to doing this well. And the Docker tooling for VS Code and Visual Studio try and handle this for you. But as you can see, like, you have to know how to correctly copy the project into the Docker file. You have to know to separate, restore, and build and publish for best performance. There's a lot that you as a user have to stay on top of. And so the second way that we use to create packages these days, or containers these days, is actually the .NET SDK itself. And so if we see here, I'm in the .NET Docker directory, and I have both my store and my products projects. I can actually containerize everything in my solution with one command. A single .NET publish command. And I can even clarify some things. I can say that I want my OS to be Linux and I want my architecture to be x64. I can change my architecture if I want. I can change from libc Unix like Ubuntu and Red Hat to ARM-based Linuxes like Alpine very, very easily. And actually that should be Linux Musel, right? These are normal .NET commands, but with just one slight change, you can get a container. And it's pretty fast. So if we look at this, we have, restored our projects. We're beginning to do the publish. And then finally, we are building container images on top of base images. So the .NET SDK looked at our applications and said, these are web applications. So we need the ASP.NET base image. And because we're targeting .NET 8, we need the 8.0 version of it. And boom, we're done. Both projects built into containers. That is pretty easy. And most important to me, that's something that stays up to date as I change my application. If I go update my target framework, for example, for the store project, and I've got my .NET 9 SDK because I want to try the 9 previews and I'm ready to see what's new. Like, I can change this to .NET 9 and the tooling will just work. I can change my application to use AOT publishing and I will choose a different base image that is more optimized for my application now. There's a lot of intelligence in the .NET SDK now to learn about your project and help you make good containerization decisions. So that's one of the many reasons why I love this tech. So containerizing was super easy. Does anybody know what's actually inside those containers, though? I'm kind of curious. Just let me know in chat if you want to know what's inside those containers that we just built. I'm seeing a couple comments. There are people saying, yeah, there's a Linux OS in there. There's a stripped down version of a Linux OS. That's exactly right. Martin says that a CLI command is all that it takes. And the answer is yes. For most projects, a single CLI command is all it takes to build a container now. There are some cases where you still need a Dockerfile, but we tried really hard to eliminate those as much as possible. So we're seeing some folks in chat that do want to see what's in our container images, I just wanted to show that, those images that we just made, Docker does see them. When we run Docker image list, we can see that the products and store images are listed here, and you can see their sizes and when they were made. So they do exist in the tooling, and we can actually see that as well. We can see them in the VS Code tooling for Docker. Our images are listed, and they're right here. But one thing we can't really do is see inside them, and that's what I'm really curious about. And so I've installed an extension called Dive. It comes with or you also need to install a command line tool called Dive. But one thing I like about Dive is it lets me sort of visually inspect what's inside my container. And so I'm going to go run this real quick. And now we get a really cool terminal view that lets us see the details. And I see a comment in chat that I really agree with. The comment in chat says, command lines, it's hard to remember everything. Totally agree. For Dive, for example, that's why I liked having the editor integration to click Dive, right? We try and build good, powerful experiences at the command line and then build nice, usable experiences on the UI on top of that. There's a very important question from Pavel in the chat who said, does this CLI tool in the .NET SDK create the needed Docker files? Actually, no. It turns out that you don't need a Docker file to create a Docker image. And that's actually what we're going to see now. So in this Dive view, what you see is the image layers. And I may have to zoom out a little bit so we can see them. I promise I'll zoom in a second. But what you're seeing on the left here in this layers section is all of the commands in the Docker files that were used to start from Ubuntu, update the dependencies, create a user for your application to run as, copy in .NET itself. So the .NET runtime and the tooling that's required, and that's this layer and setting up all the symlinks. And then this layer, which is 24 megs, copies all of the ASP.NET binaries that you need to run. And then this final layer looks a little weird. It doesn't say run or copy or from. Instead, it just says that the .NET SDK made it. That's because this layer was made by the SDK without a Docker file, just by constructing the core components that an image is made of. An image is a JSON file and a bunch of tarballs, a bunch of archives, if you will. Each of these layers is a separate archive. And so the SDK can read that JSON, can manipulate that JSON, and as of .NET 7, it can create archives. So we can do this without Docker files, and in fact, you don't even need Docker installed to make these. You need Docker installed to run them, but not to make them. So there are a couple of questions in chat. The first is from Gohaku that said, this is so cool, totally agree. Dive can help me debug a Docker container. Sort of. What it can help you do is understand where the contents of your container are coming from. And with this view on the right, actually, you can actually do things like toggle out directories you don't care about and just see what changed, right? So you could, for example, go layer by layer and just see like which binaries were added on each layer. The tool is having a little bit of frustration in the code space, so I kind of lost it. But it will let you go layer by layer and see the contents, and you can also do things like see the size. If you want to debug the image, then you will need to run it still. Okay, so actually debugging your code still requires executing the Docker image. Ginny Shuns said, are you using .NET Core for this? Yes, absolutely. As of .NET Core 7.0, I think 200, we started putting out a NuGet package that had this functionality. In 300, we started including that NuGet package automatically for ASP.NET Core applications. And then in 80100, we actually started baking the functionality into the .NET SDK itself. So Johan said .NET 8, they are exactly right. From .NET 8 onwards, everything you need is in the .NET SDK and ready to go with no external dependencies. Pavel said, what would be a cloud deployment workflow if we're using this method? We need the Docker images in order to deploy them to a cloud. We're actually going to see that in part 2 pretty nicely. In general, the flow looks like use the .NET SDK to make the images and push them to a remote registry like Docker Hub or Azure Container Registries or something like that. Once they are in those remote registries, you have some other process like a Kubernetes deployment or an Azure Container Apps that is looking at that registry, sees that there's a new version, and deploys it. Right? You see a lot of CI/CD pipelines that do this kind of thing. They will push the image, create a new deployment, pull the image. So it's a really nice setup once you get it. Few other questions about Dive. It won't help you inspect for malware or a virus that live in memory, but if there is like a file in the layer, you could see it. Really, it's a developer aid more than anything else. And yes, Dimitri, Dive is an extension. Okay, there's a question in chat that says, which layer copied the application code? That is almost always going to be the very last layer. So in general, when you're looking at output like Dive here, or when you're doing Docker image history from the CLI, the first layers are all going to be your dependencies. And it's often your operating system. And then your languages runtimes are the next layers. And then the final layer is often your application. And you can actually see that over on the right here, if my tab button would work. But it's stuck, so it won't. But this section with the app has all of the the store dependencies in it. So it has the store executable, store.dll, your app settings files, and all of your static assets. So this last layer is the one that contains your application, almost always. Yeah, so it looks like we're good, and we made some containers. So we basically did the entire bullet point in one command, but I wanted to spend some extra time talking about what happened when we did that. And actually, let me bring up the terminal and show you how you can check that there. So if we do Docker, I think it's history. Yeah, Docker history store latest. And we look at it, we get a different view with a lot of the same information that we just saw. I'm going to zoom back out for formatting purposes, but in this case, we see the top layer is our application, and then all of these layers came from the .NET team that made the .NET base images, and then all of this below comes from Canonical making the Ubuntu image that this is based off of. All of these things are things that you can control, right? We didn't specify one here. We let the .NET SDK choose for us, but you can also do things like container base image, ncr.microsoft.com, .NET, ASP.NET 8.0, and choose, maybe I'm feeling very secure and I want something much more locked down. And this is a way that you can use to choose a completely different base image for your application. But you don't have to use the Microsoft provided .NET images. If your company has, their own customized based images, you can specify them here and the tooling will use them. And if you mostly want to use the .NET Microsoft images, but you just want to change one small thing, you can even use properties like container family to specify just a different variant of the ASP.NET images, right? In this way, you can look at all of the different images that Microsoft or your company or whoever provides and choose the one that fits your application best. The .NET SDK will, like I said, look at your project and decide what it thinks is best based on properties like invariant globalization, or if you are publishing trimmed or using AOT or anything like that. But as always, you are in control. And there's actually a question in here that's in chat that's directly relevant from Anton. In the case of ARM target platform container, like what will be, like, will the architecture of my container match the architecture I asked it to build for? And the answer is yes, 100%. When we did the publish call here, we specified Linux x64, but you can also specify ARM64 right here. And this will work for Ubuntu on, let me zoom in a little bit to make that clearer. So this will work for like Ubuntu or Red Hat for ARM64 versions. If you want to deploy on Alpine, then you would use a command that looks like this and deploy on ARM64 Alpine or, you know, x64 Alpine, right? And the .NET SDK tooling will automatically choose the base image that is that will work for you. So instead of having to specify when you say Linux Musil x64 that you want to use the Alpine base image, the SDK will do all of that for you. So you just have to think in terms that you have already been thinking of. What OS do I want to use? What architecture do I want to use? And the tooling will back you up the whole time. So we built our images. So how can we actually like do something with it? We need to actually put our image somewhere so that we can use it. And so what we're going to do is we are going to push these images up to, we'll say, Docker Hub, so that we can use them in the rest of the application or in the rest of the session today. You can do this from the tooling. You can do this from the command line. I like doing it from the tooling just because I normally do it from the command line, and I like to be different sometimes, you know? So I just logged in to Docker Hub. You can see some of my pre-existing data here or images here. And I'm just gonna, you know, push the image, the store image and the product image up to Docker Hub using this UI tooling because I feel like it. But you can see all that it's doing is calling Docker image push this thing, right? It's doing the command line operations behind the scenes, but it is giving you a nicer interface to it, okay? So, yeah, so we've got our images in our Docker Hub so that we can do something with them. And at this point, I think there are actually a couple slides for us to talk about before we go on further. So we've made containers, but we need to do something with them. And this is typically called microservices orchestration. You need a tool that understands what a container is and will let you say things like, hey, give me 4 of these and put them behind this URL with a nice name so that there's always one available when I hit it if one goes down. Or you need a tool that will help you define when to create more instances of your application when you get a spike in usage or experience heavy load. All of these things, including managing the deployment of new versions or managing the infrastructure for them, it all kind of comes under the umbrella of microservices orchestration. And so we're going to talk a little bit about that. They need a tool that helps our application, our Contoso company, to manage, scale, and maintain their application because they have been deploying it manually via containers. They've been SSHing onto a VM and they've been running Docker pull and Docker run to create their containers, but they want something that does this a little more automatically for them. this is an example of the kind of architecture you might end up with when you use tools like Docker Compose to manage how you run your containers. You typically have some kind of file that describes the state you want to be in, right? Like the number or the kinds of images you want to run, the number of images you want to run, how to connect them up to each other, and how to actually do something useful with them. And then you give that information to a tool, and that tool makes it happen, right? How it makes it all happen is going to change tool to tool, but there are a lot of commonalities between like Docker Compose and Kubernetes and even Aspire these days. You can often use different kinds of orchestrators for local development and your production development. So you will often see people using like Docker Compose to make it easier to run containerized apps locally, but they might shift to Azure Kubernetes Service or Kubernetes directly for their production deployments. So Compose is what we're going to try and show today. It is a fairly easy way to get started and have one tool that can stand up your backend and your front end so that you can test things and ensure that the system is working as you expected. There's a big note here about Docker Compose. Generally, people don't use Docker Compose in production anymore. There are some more broadly used orchestrators like Kubernetes that you would use for that purpose instead. And we'll get to Kubernetes here in just a bit. So before we go hands-on, we talked a little bit about orchestrators and why you might want to use them. Do a quick one-question brain wake-up quiz and then get right to it. So what is one use case for an orchestrator? To scale out and manage complex distributed systems of microservices, to hold your Docker images in source control, or to automate security penetration testing? All right, Martin and Vlad and other folks are on the ball with the chat, seeing tons of A's. I figured you all would get that. You're all dialed into containers now. It is, in fact, A, to manage the deployment and running and connection of multiple microservice systems. We haven't actually looked at Docker Compose yet, so this one's on me, but it's a YAML file. We're just going to give you this one because I haven't shown it yet. And we're going to see an example of what a Docker Compose file that you might use for the sample application is right now. So if we go back to the code, yep, looks like we're there. Great. Okay, so we're in the same repo, and I'm going to make sure that the size is right. There we go. We're in the same repo, and we still have our products and store projects, and we've pushed images for them elsewhere. But we want to like run it locally. We want to make sure that they can talk to each other and that our UI is receiving data from the backend and that everything's working. So we're going to make a file called Docker Compose that Docker can use to create the images we want all at once. So I'm just going to paste some content in here and we'll talk about it bit by bit. So in a Docker Compose file, you have a concept of services, and these services are named. So we have a front end and a back end. Each one of these services needs at minimum the name of the image that it is going to run. There's also other configuration that you can do, like setting up environment variables and setting up port bindings. And that's what we've done here. So what we've expressed in this file is that we have a backend that is going to use our products image that we just made, and it is going to bind to port 32001 in our environment. And that is going to map to port 8080 inside the container because, as we said before, as of .NET 8, all ASP.NET applications bind to 8080 by default. So that's our backend application. Our front-end application is going to use the store API, and we need to tell it how to reach the backend. And this is where things get really interesting. This is a list of environment variables, but we're saying the product endpoint environment is pointing to this URL of HTTP backend 8080. That's weird because I don't remember setting up DNS so that the name backend is available. And I didn't actually set up DNS so that backend is available. That's a feature of Docker Compose. What you can do in Docker Compose is reference other services by name and let the engine fill in the networking configuration so that the front-end application will see backend as a viable URL and navigate to it. So this is one of the most useful services that an orchestrator can do. It can let you decouple the details of how your services communicate and put in some kind of name-based layer there so that humans can actually understand what's going on. So there is a lot of tooling around these files that you can use to help you understand what values are valid when, but this one is now valid. We're just going to accept that as truth. And we're now going to run this. There are a few different ways you can run it. If you have Docker tooling in your VS Code, you can actually like right-click on Docker Compose files and say up and have it run. But we're actually going to just use a normal terminal here so you can see that. So here we are in the same directory that, oh, come back here, in the same directory that has my Docker Compose file. And we're going to run Docker Compose up. And this is going to do a few things. Well, first, it's going to dump a whole bunch of logs. But what we can see here is that it created a network to sort of isolate these two containers. And then it created a backend and a front-end container. And then it started, dumping out logs. But it also set up some ports. So I'm going to open up some links for these two ports that we just made. And this one that we have open now, make sure you can see it, is our backend. And you might be saying, well, it looks like our backend is broken. Well, that's just because we didn't go to the right URL. Here's our backend. It's running inside a container, and port forwarding worked and code spaces forwarding worked. And so we can actually hit it as if it were local to us. And this URL is our storefront working. And if we want to confirm that it can communicate with our backend, boom, here we go. We go to the products page and it has pulled data for our products. So a Docker Compose file is a really great way to sort of test the communication between your services. There are alternatives that you can use today in .NET, like Aspire, that are a little bit more integrated into our tool chain. But Docker Compose is like, there's so much examples. There are so many scenarios that you'll find out there. It has a lot of learning resources. So it's a good tool to have in your tool belt anyway. That is a very basic introduction to what we call microservice orchestration. So some of the key things that we just did there were define, we gave names to our services. We defined how to configure them. We defined how they communicate to each other. And we put it all into a reusable format so that you could like share this across your teams now, and everyone on your team would have a consistent way to test that your applications were working. So I've used Docker files in so many of my previous jobs for this very reason. It's also great not just for your applications, but if you have like a database dependency like PostgreSQL or SQLite or anything like that, or Redis, you can often include those as well into files like these. It's the number of times I've written something like is very, very high. So it's a great way to manage your dependencies all together as well. So that is Docker Compose. I'm going to hit the questions now and see if there are some that we should take special care to answer. So Marshall, a little bit ago, asked, so .NET Publish can publish Docker images and exes previously, right? How to configure that command. .NET Publish is using MS-Build under the covers, so you can use MS-Build properties to control what happens. In our case, when we ran the, let's see if I can bring that command back up again. When we ran the publish command, I added a new parameter to it, tpublish container. This says, hey, .NET, publish, but also run the container publishing target as well. And if you do that, it will do both things. It will build both the sort of executable version that you're used to, and then on top of that, you will get a container as well. You don't have to build a container when you publish. It's a purely optional thing, and you can use other MS-Build properties to control how that container is built if you want it. Martin had a follow-up question about the Docker Compose experience, asking how the front-end service gets the correct endpoint to the backend. Is it naming based, or does it have to do with the depends property? And it's a little bit of both. The depends on is more an ordering constraint. So if you look at the tooltip here, it says those services will be started before this one. This one is a nice to have, right? So you can write your systems kind of two ways. You can write them so that they have a hard dependency on some other service being up and active and live, or you can write them such that they do like a poll, a recurring request to see when their dependencies are live. That can be hard to get right though. And so you can often do things like depends on to let the engine handle the ordering, right? So in a more complex example, you might have a PostgreSQL backend that your backend project needed. And so you could imagine a world where backend had a depends on a Postgres service that you made, right? Right. And if you did something like this and ran Docker Compose up, you would see that first Postgres would be downloaded and started, and then the back end would be started, and then the front end. So it's an ordering thing. The reason the naming works is actually because of the networking rules that we chose. So if I bring the terminal back up and scroll up to the top of what Docker Compose up said, the very first thing it did was make a Docker network called .NET Docker default. This network is unique to the containers that are in this Dockerfile, and it acts as sort of like a virtual boundary. And inside that boundary, the engine makes these names, front end, back end, Postgres, etc., available as valid URIs, right? As valid names that you can target. So that's all handled by the engine. So we did some Docker Compose here, and this is where the first module ends. But I think we can go a little further. So we talked about our microservices. We talked about why you'd want to build microservices. We talked about packaging them in containers, and we talked about an orchestrator that you can use to run them locally. There are a whole bunch of resources here, and I know that Jamie's been on point with the chat links that that have been going the whole time. There's a whole bunch of documentation about containers themselves and .NET with containers that I really encourage you to go look at there. But I think we can take this a step further. We've done the local case. I would really like to see, well, let me do some closeout here first. This link, this Cloud Skills Challenge, is a really cool experience. If you click this and go through with it, and Jamie maybe has more details here, but there's like a whole experience you can go through to test your knowledge of some of the concepts that we talked about tonight. Jamie, do you have anything you'd like to say about this specifically?
Oh, there we go. It didn't like that for a second. Yeah, so we've learned a lot today already. If you want to go ahead and test your skills, oh, I'm gonna mute you. If you want to go ahead and test your skills on everything we just learned, we do have a cloud skills challenge where you can walk through the modules and get points and certifications for completing this, the learn modules. We have it all set up for you. You still have 24 days to complete this challenge. You can do it all on your own time. And then you get a badge, which is really fun. So feel free to head on over to that link. I've also pasted it in the chat for you all, and see what you've all learned.
Awesome. So this was kind of our first checkpoint. We covered a lot of foundational material here, but there is like a next step that I think we can tackle too. I think we can make the jump from local development to something that's more production-like. So as we were working through some of the examples there, we mentioned two concepts a lot that I want to dive into a little more. One was container orchestration kind of generally, and the kinds of capabilities that it can give you. And the second was Kubernetes. And I think we have enough time here to talk a little bit about Kubernetes and to get a hands-on example of using it with the same containers that we just made. So as before, there is an entire Learn module that you can go to and follow along here that will take you from zero to running Kubernetes cluster with your applications on it, like in no time flat. So let's do that. We're going to skip some of the high stuff. I said hi to you folks already. We're all here. We're all having a good time. We just covered most of the prerequisites here. And now, especially the second one, now that we just went through the past hour and change, you're all familiar with microservice designs. So we're going to have a good time going on here. We are going to build on what we just did. We're going to push our images to Docker Hub, which we did a little earlier, but I'll touch on again. And then we're going to use those publicly available images to build a Kubernetes cluster. So, and then we're going to show some of the cool things that a Kubernetes cluster specifically gets you. So some of the framing of this is we have these same product services and we want to go to production now. And not only that, we want to be resilient. We want to recover from failures well, and we want to do so in a way that doesn't require us to do anything, right? If one of our services goes down and we are, it's Saturday night, we're out with some friends at the movies, we don't want that phone to ring, right? And so we're going to see some of the capabilities that Kubernetes brings that lets us breathe easy. We talked about orchestrators a bit before in the previous session. The main things they do for us is control the way our containers are run. They give us a framework, they give us some patterns that we can use to control when they can be restarted, how they communicate to each other, how they are configured, right? One of the biggest things they do for us sorry, I read Whiskey Tango, their comment in the chat. He said, what do you mean? I'm coding Saturday nights, haha. More often than not, me too, friend. More often than not. But the big thing orchestrators do for us is that resiliency I was meaning. Another big thing they do, scaling. We talked about scaling way at the beginning of the first session, and it's coming right back now. Orchestrators let you define min bounds, max bounds, and you can configure them to dynamically move between min and max bounds when certain conditions are hit. These might be things like, hey, if the CPU is staying above 50% persistently for 5 minutes, maybe I should create more instances so that I'm not pegging my CPU at maximum all the time. Same for memory, same for any arbitrary metric. You can go really deep on this. We're not going to go that deep today. We're going to give you a taste and then show you where to go next, okay? So we talked about the management of containers. We're going to show an in-depth example of this today. We're going to make a thing. We're going to make a Kubernetes cluster. We're going to make a thing called a deployment, which is going to describe how our containers will be actually run. And then we are going to describe how they should recover from failure, right? We're going to use this deployment to dynamically adjust the number of container instances that we have. And we're going to show how being able to describe this in one place really frees us from the potential of making mistakes, right? Anytime you've got a human in the system, the human can mess this process up. So we're going to automate it. Said Kubernetes a bunch. Kubernetes is a huge containerization management and orchestration framework. It does so many things, way too many things for us to cover here. We're going to just scratch the surface of Kubernetes and then point you to where you can go learn more. Kubernetes is a huge topic. There's a lot to cover, but it's one of those things that as you learn each core concept, you will see it come up again and again and again. And I will try and call some of those out as we look into it more, okay? We've talked about several of these benefits before. You're going to see them in action. You are going to see us set up a cluster that has a bunch of different containers in it, and then just stop some of the containers and watch them come right back. We are going to make a system that no matter how many containers you take down, cannot be taken down, okay? It's going to be super fun. And using these same core primitives, we'll show how you could manage live updates for these kinds of things. So before we dive into it, just a couple more quick questions. I got to make sure you're on your feet and you're thinking. Why is a container orchestrator useful in a microservice architecture? Feel free to tell me in your own words too, if something that we've said or something you've done in the past has been useful to you. Are they useful because every microservice needs to be maintained and deployed individually, and an orchestrator can help manage that? Is an orchestrator useful because it holds instructions on how to build and version the Docker images themselves? Or is it useful because it's the only means by which you can run a containerized application in the cloud? Wow, people are on the ball. Some people are so on the ball that they're submitting multiple answers, and I love the enthusiasm. Yeah, you guys are right. It's A. So each application we mentioned before, in the world before containers, every application had its own deployment script or had its own deployment methodology. Those needs are still there. You still need to put the bits somewhere. You still need to configure them somehow. It's just an orchestrator gives you a consistent way to manage all of that. So let's do it. Switching back over to the code, we have the exact same code that we saw before, okay? I'm going to move down to the .NET Kubernetes entry here. It's the same code, just a few pieces missing, like all of the manual bits that we did before. So if we want to use Kubernetes, we first have to get Kubernetes. And if you're following along with the examples at home, we're just going to do those real quick. All right, so we're in the Kubernetes directory. We're just gonna, oh, I'm already there. We published our containers already. I already pushed them to Docker Hub, and we can verify that. We've got our store and products images all good to go, and we can see them on Docker Hub here. So we've taken care of all of those prereqs, but we need Kubernetes, right? If we're going to deploy to Kubernetes, we need Kubernetes installed. And so I'm going to install Kubernetes and also make sure I've got the Kubernetes extension because I enjoy what it can show me. So we've just installed Kubernetes, or we've installed some prerequisites for Kubernetes. This is all just grabbing some packages. Okay, that exists. Do I have kubectl already? Awesome. I do have kubectl already. So then the last thing that we need to do is actually make our own stripped down version of Kubernetes. And we're going to do that with a tool called K3D. K3D is a version of Kubernetes that is optimized for working like locally. It cuts out a lot of the bells and whistles and gives you just what you need to be successful locally. And the way, like many things in Kubernetes, this is YAML. You're going to be seeing a lot of YAML over the next little bit. We'll dig into it a little more in context, but this command is going to grab the K3D tool and it's going to create a Kubernetes cluster using this configuration. And it's going to do a bunch of things. We're going to look at what those things are real quickly. If I come over here to my extension, we can get a nice visual representation of some of the things that are going on, okay? Unable to list repos, that's exciting. Okay, that's up and running. There we go. There's our cluster. It just took a second. So there are some interesting things I want to point out here. All of these tabs, these are concepts in Kubernetes. Namespaces are how you isolate your applications and their resources. Nodes are the actual hardware that you are running your applications on. Workloads are the ways that you run your application. Deployments are descriptions of how your application would like to be deployed. Pods are actually how you run it. The network services are how you connect to the different applications you have running. So all of this, these are the concepts that Kubernetes will teach you. We're not going to go deep on all of these. We are mainly going to look at pods, deployments, and services, because that's what's useful for us right now. The examples in the Learn module give us ready to go examples of all of these things. So we're going to start from there, and we are going to sort of look at them one at a time. So the very first thing we need to do, because we know our application needs it in this order, is we are going to make a deployment for our backend. So we're going to tell Kubernetes how our application for our products service should be deployed. There's a little bit of changing from the template that we have to do here, but what we are looking at is a concept in Kubernetes called a deployment. And we're saying there's going to be one replica in this deployment, and the container in this deployment is going to be our product container from Docker. And this container is going to be listening on port 80, and we can set some environment variables to change how the application behaves. Okay, this is very similar conceptually, sorry about that, to what we did in the Docker Compose a little bit earlier, okay? But this is how Kubernetes expresses that concept. This service is how you tell Kubernetes, oh, but I need to be able to reach this, our application over the network. So that's what we've got pre-generated for us from the Learn module. And so now that we have this, we are going to what's called apply it to our Kubernetes cluster. And so that did two things. It created a deployment and it created a service. So if we go back to our Kubernetes here and we refresh and we look at our deployments, we can see that the products backend is there now. And if we look at our pods, we see that there is a products backend pod that is pending. And we can check all of this same data on the command line. We can say kubectl pods or get pods. And we can see, oh, this. Okay, so it didn't run because the deployment was incorrect, because I probably messed up the name of the image that we need. So if I go back to Docker and I look at registries in Docker Hub, it's products, not product. So we will just redeploy this. And it changed the deployment, but didn't change the service. So if we go back to Kubernetes and we refresh this, there we go. This one is running. Huzzah. All set, all good to go there. Let's zoom this out just a little bit. Cool. So that's all we had to do there. Boom. So we can reach that application that we just deployed. No problem. What we can't do is reach our storefront. And that's because we haven't made a matching deployment for the storefront. So let's do that. Let's go back to our code and let's make a new file. Frontend deploy.yaml. And just like before, we get an example of this from the learn module, and we just have to go in here and make sure that we type the right things, which, as we all just learned, I might not do. So let's double check. It's chusk3 store. chusk3 store looks good to me. So we'll come back to our terminal, and now we will run the front end deploy. And just like before, we get a new deployment and we get a new service. We're going to flip back over to the Kubernetes display, refresh it, and we see our store front end, which is great. And we see our store front end pod. Perfect. Everything is working exactly as we hoped. Let's open up our view. Boom. We got our new version of the application. And it's even talking to the Kubernetes hosted version of our backend. That was a lot. That was a lot of stuff all at once. We didn't super go into details, but the thing I want to call out here is the relationship between the replicas that we've requested for our front end and our back end, and the number of pods that we got. There is one pod and one container for both of these. All right. So what happens if something goes wrong with our product? Like if that service goes down, like our front end might not load. Of course, we're working in Kubernetes and we've asked it to provide us one. So I'm gonna cheat here. I'm going to say that I want to have 0 replicas, and we'll see what that looks like. Oh. Third time's the charm. Okay, so refresh this. That should update. Yeah, perfect. Okay, so we no longer have a product service that works. Maybe that was because there was a network interruption. Maybe that's because there was a logic error in our application. But now, as a result of that, we can't view any products. We have no data. The beautiful thing about container orchestrators like Kubernetes is they give us tools to help manage what should happen in this scenario. So if we come back to our deployment, or even just on the command line there, we can do things like this. We can say, give us 5 of them. And if we wait just a moment, we can see in our deployment 5 instances of our product service running in the background. And this means our app is much more likely to have an endpoint that it can hit, right? And this means I can start playing Chaos Monkey, as someone in the chat said, and I can just go through here and I can delete instances left and right, and nothing bad will happen to my service because I've thought about that failure mode and I've ensured that there's redundancy. I'm being very specific right now. I'm being very explicit in saying, hey, always use this number of replicas. But many of these container orchestrators give you tools to define what that scaling should be. You can be simple like this and say there's always 5. You can be complex and say, when my CPU is low, go down to just 1. But when my CPU is super high, go up to 6 or 7, right? The only practical limits are the amount of engineering time and the amount of money you are willing to spend, okay? And so at this point, I want to pause and field some questions from the chat. So first off, hi, David. Glad you could join us. I too love containers. That's why we've been talking about them for the past hour and some change. Ginny Shans, I think this was covered in chat a little bit, but you asked, what's that Docker hub we referred to? This is actually a really great conceptual question. If I go back to my Docker tooling view here, Docker Hub was under this concept called registries. We talked about this a little briefly in the previous section, but remember there are sort of 3 components to Docker. One is building containers, one is running containers, but the third one is storing containers. And that's what registries are. Docker Hub is a publicly available registry run by the Docker company. I don't know why that word was so hard for me to find, but they host a very large number of publicly available images that anyone can use. Examples are base operating systems, right? But a lot of tools will be put up there. For example, the dive tool that I showed earlier actually has its own Docker container that you can find on Docker Hub. But it's also very common for like cloud providers to have container registries. Azure has the Azure Container Registry. And this is often very useful because you want those images to be close to your compute so that you're not having to cross networks to download the data, right? Docker registries there's a spec behind them. There's a certain HTTP protocol that you have to know, but anyone can make them and anyone can use them as long as you can authenticate to them. And that's something that both the .NET SDK tooling and the Docker CLI tooling that we've been using both know how to do perfectly well. It looks like, yes, Richard asked, is this load balance behind the scenes? And I believe you're referring to, when I could go back to my products page here and refresh a bunch of times and hit one of my service instances. Yes, this is being load balanced. And this is one of the things about Kubernetes services. So because we are teaching our containers to communicate to each other via names, via names like products backend, the Kubernetes networking layer is able to say, hey, product backend actually points to any one of these instances. And this is this is getting into a little bit of the nuts and bolts of Kubernetes, but the way this works is that when we wrote our applications, we added a label to them. And we said, hey, every single one of these applications is going to have a key called app and a value called products backend. And then we defined a service that says, hey, this service maps from port 80 to port 32001 on the containers. And it does this for every container that has this piece of metadata on it. And because the metadata on the service matched the metadata on our application, we were able to get to any one of our application instances via name. So this is actually more apparent on the front end deploy, because on the front end, we have told the application, hey, the product endpoint is just called products backend. So just like on the Docker Compose example, when we were able to use names to reference resources, we can do the same thing here. And this, again, is another thing that Aspire has really leaned into. You can reference your projects in an Aspire project when you're running locally by name. So yes, load balancing is key to enabling a lot of these experiences. Okay, a couple more questions. So we're at the tail end, kind of the examples now. This example of scaling and of purposefully destroying instances and seeing how the system can react, that is all about showing some of the capabilities of Kubernetes. And the key takeaway that you should have here is that we defined the way we wanted the system to be and the way we wanted the system to behave. And then it was the job of Kubernetes to make sure that real life matched our expectation, right? We didn't necessarily have to say, go spin up new pods. Instead, Kubernetes said, hey, the number of live pods is less than the number they asked for, so please make one, right? This is, you'll find parallels to this all over the world, or all over the tech world. If you've used PowerShell, for example, for system configuration, you might be familiar with the term desired state configuration. That's what's going on here. We're describing the desired state, and the system is making it happen. This is also how things like Terraform work, or Pulumi for managing infrastructure as well. Very common concept, and this is one more example of how learning good cloud native principles, you start seeing them again and again and again in different areas of your tech life and your career. So it's really a good investment for an individual developer, I think. So we've done the content now, and I'm happy to go to questions and like dig into details at this point. Jamie, what do you think? Like 5 minutes left, give you the time and space to give us a proper send-off? That sounds good to me. I'll wait for feedback from her. But in the meantime, we got a good number of questions. Jamie, what do you think?
Yeah. So we have a good number of questions. I was just going to keep like shelling them off to you, and you can keep answering. We have a few more, and we might even end on time.
Oh my goodness. Amazing. Cool.
So
well, let's just turn through them.
Perfect. I'll keep sending them to you.
All right. Sweet. Oh man, I love when people give simple questions. Needed water for this one. So I'm going to be very clear before I start answering this one. We're going to enter opinion zone at this point. Okay. I will try to be very clear when I'm saying something I believe versus something I've experienced versus like something the industry promotes or something like that, right? So Nisitro asked, what are the best practices to follow when implementing microservice architecture, container orchestration? What habits should we be wary of and potentially avoid? Man, so this is a big, broad topic. We talked about some of the technical side of it a little earlier in the previous section. So when you're defining your microservices, you want to define your API specs in a way that you can share with others easily. This is very popular to do with tools like OpenAPI. And ASP.NET, minimal APIs really lean into this, right? When you're using .NET out of the box, you will be generating these OpenAPI description documents. And then others can use these description documents to generate clients for your API that are correct. Okay? That is like bare minimum for me. You need to be generating OpenAPI, and people need to be using them to power their queries, right? That helps ensure that you don't have drift. So that's step number one. But as is so many things in technology, the most important thing to do with microservices is not a technical thing. It's a person thing. You need to communicate with your users. Microservices just give you a vehicle for doing that early and doing that often. I'm biased because I'm a product manager and communication is so much of my job, but you cannot technically solve communication problems. So just be aware, microservices, like all development, will require communication. On container orchestration, one thing we haven't done here that you should consider doing is applying limits to your pods, to your containers. So this is something that you would do in the spec for your front-end deployment, for your back-end deployment, but you should specify, this container should only use this much CPU or this much memory, okay? If you don't do that, you'll be what's called a noisy neighbor. So when you're running these containers, they're all running on the same nodes. So even when I said, spin up 5 products in one storefront, they are all running on the same server. And in fact, internal containers that Kubernetes uses also run on some of the same hardware. So you can't escape the realities of running on other hardware. And if you are good and consistent about specifying your CPU usage and your memory usage on your container definitions, then Kubernetes and other schedulers can more efficiently distribute them to the hardware. Okay. I did not do this when I was starting, and I caused a few outages because you'd get somebody that would like spam one of your endpoints, cause its CPU usage to spike, and because we hadn't set limits, that one pod would take down the entire piece of hardware, right? So just be proactive on your limits. I've been out of the game for defining Kubernetes configs for about a year now. The most important thing you should do is actively search out best practices, all right? So we touched on Kubernetes kind of tangentially here today. You should do your due diligence, and you should go to the Cloud Native Computing Foundation's websites for Kubernetes, and you should be aware of their security best practices, right? Just like you should be aware of patching your host machines to prevent like OS critical vulnerabilities, right? Having a container orchestrator does not solve all of your problems, and you need to be aware of the way this tool behaves the same way that you would be aware of how the .NET CLI behaves or how the debugger in Visual Studio behaves. It's another tool in your tool belt that you have to educate yourself on, okay? This is just life of being a developer. There's always another thing to learn. Yeah, Cayenne in the chat asked how they can start a K8s cluster, which K8s is short for Kubernetes, in their laptop easily. They just got started with K8s and they're using Minikube. Minikube is another great way to get started. Today, we used K3D, but when I was first playing around with Kubernetes a few years ago, Minikube is exactly what I used. You wouldn't be able to use necessarily the same components that we used today. Some of them you can because they're part of base Kubernetes, but many of the concepts would map across. I'm sure that there are other examples for Minikube that would be more copy-pastable, but the core concepts that we've been talking about around deployments that define pods and services that map to pods, these are things that are pretty stable and don't change. So they should work pretty broadly. Okay. Looks like Ginny in the chat, Ginny or Jeannie, I'm sorry if I'm mispronouncing your name, asked, can we provide the Docker image which has built-in .NET 8 or Core to try the examples we've shown here? So I can actually do better, like one better. This code space came from the mslearn.net Cloud Native GitHub repo. And inside this repo, there are dev container descriptions for each of the learn modules. So there's one for .NET Docker, which was the first module we did. And then there's one for Kubernetes, which is the second one we did. These will let you spawn a code space environment like with a single button click. It was honestly pretty amazing. I set these all up a couple days ago, and it took like 3 minutes to go from 0 to ready. All that these things do is pre-provision some software and pre-provision some VS Code settings. So I would definitely encourage you either to try those as your path to getting started, or to use them as a reference for what software is installed so that you could install it on your own, right? Really awesome stuff here. Like the fact that I can start playing around with this in a couple minutes, and then when I'm done with it, just delete it and it's like it was never there, is very handy for experimentation. There are a lot of comments that are very gratifying to read. Thank you so much for those, but they're not questions. So we're ooh, here's a really good one. Alejo. Yes. Alejo said, me again, what about mapping port 80 to port 8080 on Azure Container Instance if I'm not using Kubernetes? Thank you for your question. This is actually the perfect time to talk about it. So you have two routes. You can either change your container image to not use 8080 by default, or you can change your container host to understand the change to 8080. So here's an example of what it would look like to actually change your image to use 80 again. It won't look exactly the same for you because you are using Azure Container Instances, but this is effectively what you need to do. You need to set the environment variable ASP.NET Core URLs to a value like HTTP *80. The ASP.NET Core URLs environment variable is a documented way of changing the port and host that your application binds to when you run it. So this is one way that you could change that default of 8080. If you actually, I can show this in Dive real quick. If we go look at our container images, you can see where the 8080 default is set. Or you could if I chose the correct image. Let's zoom out a little bit. Where did they do it? Maybe it's the other one. So this was products. Let's try store. Oh, you know what? This is a weakness of Dive. Dive doesn't show changes that only affect the configuration. It only shows changes that affect the file system. So I won't be able to show it to you there. Instead, I can show it to you here. Let's clear all this out of the way and go Docker inspect products latest. It's actually history. There we go. Okay, so the reason the 8080 change happened is this line right here, where it set ASP.NET Core HTTP ports to 8080. So if you set this environment variable to 80, or if you set ASP.NET Core URLs to something like this, then your application will run binding to 80. However, I strongly encourage you to accept the 8080 default. It's much more secure because your application does not have to run as root to bind to 8080. So I know we have some docs on the breaking change notices for .NET 8 on the core, .NET 8 SDK breaking change docs. I would very much encourage you to give that a look. I believe there are pointers on that to some examples of how to adjust to 8080. And if not, I'm available on Twitter. I'm available on the .NET SDK repo. You can feel free to ping me on there and we can try and get to a solution there. Few last questions, trying to wind down here. Gatsby's asked, do you know of any tool to generate clients from Open API specs? There are tons. The most common ones that I'm aware of are the Swagger generator tool or InSwag or things like that. But there are a lot of them, and I think, did I say InSwag? Yeah, like Rico Suiter's InSwag is another pretty common one. But there are at least 3 or 4 in the .NET ecosystem alone that can do this. We are just about at time now, so I'm going to kick it back over to Jamie. Thank you all for your attention and your gusto for the topic.
Yeah, thank you so much, Chet. That was amazing. I learned so much. I really hope everyone who joined learned a lot. Feel free to go test that knowledge you just learned on that Cloud Skills Challenge. I'll pop the banner up. Thanks so much for joining us. I know you're joining from all over the world in completely different time zones. So thank you for spending your 2 hours with us. Thanks again, Chet. You're amazing. Thanks, everyone. Pay attention to our next Let's Learn event happening on our Let's Learn.net page that you can find, aka.ms/Let's Learn, DOTNET. Thanks again, everyone. I did it.